Hello everybody, welcome back. Another integration technique video. In this video, we are going to learn about one of the most important technique in integration. It's called integral by parts. I'm going to show some different examples and how to solve them. Let's start with first question. The general formula of integration by part is f g derivative is f g minus f derivative g. This is the general form of the integration by part. So one of the most important part is here that we should carefully choose what we call f and that we call g derivative. In this example, we are going to call f as a x and g derivative, we are going to call it cosine x. And we'll find like f derivative, which is equal to 1, and we'll find integral of g derivative. Like we're going to find integral of g because we are going to find about the derivative of which function we are going to have, and which is called sine x. Like our g gonna be sine x right here. Our g is equal to sine x because we know that the integral of sine x is going to be the derivative of sine x going to be cosine x. So now we just write it at x sine x minus like 1 sine x, which is sine x, and we have dx here. Now we're going to integrate sine x dx. We know that integral of sine x dx is negative cosine x. So after that, we're gonna have this x sine x plus cosine x. This is a little bit easy example. Then in next, we are going to have some difficult example, which we are going to need the use this integral by parts 2 or even 3 times. And just keep it. Let's do another example. So we are going to have like x squared e to the power of x dx. And you already know the formula. Let me just write it again. Fg minus f derivative g. So again, we are going to call it here the fx squared, and f derivative will be the 2x, and we are going to call g derivative a to the power of x, and you know that g is going to have e to the power of x again. So we are going to have x squared e to the power of x minus the integral 2x to the power of x dx whole. Now we are going to integrate this 2x to the power of ex is equal to dx. We can take out 2 out of the integral x to the power of x dx. So again, if we integrate this x to the e to the power of x dx, so we again use our integration by part technique. So we call it f is equal to x, and f derivative going to be 1, g derivative to the e to the power of x, and g is equal to e to the power of x again, and we will gonna have like x ex to the power of e to the power of x and ex dx. And we know that integral of e to the power of x dx going to be e to the power of x again. So we are going to have x to the power of ex minus e to the power of x. So this going to have 2x e to the power of x minus 2e to the power of x. And here we're going to have x squared e to the power of x minus 2x e to the power of x plus 2e to the power of x, and we're going to have c, and that our result at the end, that will be x to the e to the power of x minus 2x e to the power of x, and plus 2 e to the power of x plus c. As you can see, we use this integration by part 2 times. Now let's look at another example. The next example, we are going to use e to the power of x cosine x. Here again, like f to the power of, we call it f as a cosine x, and f derivative will be negative sine x, and g to the power of e to the power of x, and g is equal to ex. So we will have, like, as you know, that let me write it again one more time, fg to the power derivative fg minus integral f derivative g. So that is equal to ax cosine x minus negative sine x ex dx. And now we should integrate this negative e to the power of x sine x and dx. So we just pull it again, like, and it's equal to, if we take out negatives out of integrate a to the power of sine x dx, and again we integrated ax sine x dx. So again we f will be sine x, f derivative will be cosine x, and g to the power a to the power of x, and g is equal to a to the power of x. Again we will have like fg, which is ax sine x minus f derivative cosine x and e to the power of x. Again we will have these things. Again we have the integral of this e to the power of cosine x. We have this, so we just write it. Let me just erase this. So we are going to have the same thing again and again, like that we'll have x sine x minus, we'll have this thing. We just copy the same thing, a to the power of x cosine x plus negative ax sine x. And instead of this, we just write the same thing again, ax sine x minus a to the power of f cosine x. And that's going to have some, we should do same thing again and again here. So I don't want to lose time for that things. So you can finish by yourself if you got the point. But we got the same thing again and again here. Just going to be in loop. We should do the same thing. Let's do the last example here. And last example going to be x squared minus 2x plus 1 and a to the 2x dx. So we call it f is equal to x squared minus 2x plus 1, and g derivative we are going to use like a to the power of 2x, like f derivative will be 2x minus 2, and g will be a to the power of 2x divided by 2. So we will have like x squared minus 2x plus 1 divided by 2 a to the power of 2x minus integral 2x minus 2 a to the power of 2x divided by 2 dx. After that, we should integrate these things like this one. So 2x minus 2, a to the power of d2. So we can take out this. We take 2x minus 1, a to the power of 2x divided by 2 dx. So we can eliminate this 2. So we will have x minus 1, a to the power of 2x dx. Again, we use our integration by part techniques. So we call it f is equal to f is equal to like x minus 1, g is equal to a to 2x to the power of 2x. f1 will be 1 and g will be a to the power of 2x divided by 2, and that is equal to x minus 1, a to the 2x divided by 2 minus a to the 2x divided by 4. So we substitute it here. So we'll have x squared minus 2x plus 1, a to the power of 2x divided by 2. Like I here, I just write it. This going to be here. That will be minus x minus 1, a to the power of 2x dx plus a to the power of 2x divided by 4. And we should add c. So it's end of our tutorial. So if you like this video, please consider subscription. See you in next videos.